Hey everyone. Today we are going to take a look at a specific type of free response question that comes up quite often on the AP exam. It's almost a guarantee that you're going to see one of these on the AP test. And there's lots of different questions I can ask, but the scenario is the same. Okay, and this is what's called the rate in, rate out scenario. There's no new math here. You have learned everything that you need to know to be able to answer all of the questions on this page. There's actually a lot more questions that I could ask. But again, none of it is new content. It's all things that you've done before. You're just kind of like knitting everything together. So before we dive into this, I want to remind you that calculus is typically concerned with two types of functions. We can have functions that talk about the amount of something or a quantity, or we can have functions that talk about a rate that something is happening, okay? So if I'm looking at, traffic flow at a particular intersection, I can talk about the number of cars that come through the intersection, or I can talk about how quickly they're moving through the intersection. So many cars per hour. If I'm looking at the number of people walking, or if I'm looking at people in my classroom, I could talk about the number of people walking through the door, or I can talk about how quickly they're walking through the door, okay? And so we want to be able to go back and forth between these two things. That's kind of a big picture idea in calculus. Well, if you're talking about a quantity and you want to turn it into a rate, that's what we started the year with. And that's done through taking a derivative. But the newer thing that we've been talking about, for the last couple of months is how do you go from a rate back to a total number of whatever it is that you're discussing. And that is through doing an antiderivative or an integral. And that will usually require some sort of initial value. We'll talk about that when we get to it in the problem. But this idea of being able to hop back and forth between amounts and rates and knowing which type of function you're looking at, that's kind of the most important thing about this type of problem. Okay, so like I said, this is a very typical problem setup. So we have a tank at an aquarium being filled with a hose. Water is filling the tank at a rate, red flag right there, that's an important word, okay, of this function. So this is the rate that the water is running into the tank. So this is your in function, okay? At the same time, water is being pulled out, so this is going to be your out function. And again, this is a rate of this r of t function, so this is your out. And then these problems will often come with an initial value as well. So this last sentence says, when this process begins, there's already 15 gallons of water in the tank. So that's my initial value. And I want to make it clear that this is an amount, not a rate. That's going to be important when we decide how we're going to mix it with those values up above. Okay, so let's look at some of the questions I could possibly ask you about this situation. First of all, how much water has been pulled into the reservoir after 3 hours? How much? That's an amount question. And what we have in front of us are rates, right? These are rates, this is a rate. And so to get from a rate to an amount, that's where I want to be doing an integral. So I know for sure I'm going to be integrating a rate equation. I want to look at the water that's being pulled into the reservoir. That's the water that's being pulled out of the tank, so that's the out function. And I want to look at it from 0 to 3 hours. So this is the calculation that I'm going to do. I'm going to assume that this is a calculator active question. A lot of these are. I certainly didn't write these equations to be, non-calculator friendly. We know that we could do antiderivatives and all of that stuff. These are just too gross to do that. So I just want to focus on the integral setup. Okay, I am going to show you a calculator shortcut here that I think will be helpful as you're working through these problems. And we can go over it in class when I see you again too. But what I would recommend, and feel free to pause if you need to catch up with me, is go to your y equals and let's type in both functions. So you'll see under y1, what I've done here is type in that first function. So x minus 4 squared divided by 5, sine of x minus 4 squared. And then on the bottom I have 3x minus e to the x over 2. So now would be a good time to pause and get those typed into your calculator. We don't need to graph them. I don't really care what the picture looks like, but there's a shortcut that I'm going to use on my calculator to make it so I don't have to keep typing these in over and over again. I do want to make a quick note that this is in Y1, just so I don't forget which is which, and this one is in Y2. So, in my calculator now, I want to do an integral, so math and number 9. I want to go from 0 to 3, 0 to 3. And I want to use this equation right here, but I don't want to retype that equation every time I want to use it. So I can tell my calculator, hey, go look at the equation that's in Y2 and take the integral of that. And here's how I do it. And again, feel free to pause, rewind if you need to see it again. But I'm going to go to the variables key. It's this one that says VARS. That's variables. Okay. I want to choose Y variables. And then I'm choosing function. You don't have to worry about what these other options are, but function. And look at that. That'll bring you to a list of all of your Y equals equations. Those are the same list of values that you would find here. I want to choose Y2. And your calculator will drop that in there, and then it'll handle the calculation on its own. Okay, I have to put in that it's a dx. And hit enter. And it looks like our answer is 6.537. So this is 6.537 gallons because it's an amount. So in 3 hours, the reservoir has sucked up 6.53 gallons of water. Okay, this next question is probably the most important one on the page, okay, because this is the one that's going to kind of steer us for the rest of the page. It says, write a function to represent the total amount of water in the tank after X hours. Well, when I'm talking about water in the tank, I want to think about the water that is in there initially, and then I want to add the water that has been poured in, and then I want to subtract the water that's been taken out. Okay, so how much water was there to begin with, how much water did I add, and how much water did I take away? And I'm going to name this. I'm going to give this its own name so that when I talk about it later, I can refer to it. I'm using W of T for water. This is the total amount of water in the tank at any given time. Okay, so W of T equals my initial amount was 15 gallons plus the amount of water that has been poured in. Remember, this is the rate that the water has been poured in. So I'm going to integrate it. And if I want to go after X hours, this is going to be from 0 to X of F of T. Okay. And then I need to subtract the water that came back out. So the water that came back out, I'm also integrating from 0 to X, but that's the R of T function. So at any given amount of time, so this one up here, for example, was after 3 hours, but I could go 5 hours or 7 hours or whatever. I could figure out how much actual water is sitting in the tank at that moment by taking what did I start with, what did I add, what did I take away. Now, there's really no math to do here, but this equation is going to be helpful later on in the problem, so we're going to keep coming back to this. Okay, and now is when I can start asking you all kinds of things. So like, for example, when is the amount of water in the tank at a relative maximum? Okay, well, let's think about how we would normally find, like way back when I asked you to find relative maximum, what would you do? Okay, I want the maximum of this WT function. Well, a relative maximum has to happen at a critical point, right? So let's start by thinking about where our critical point is. Well, to get a critical point, I need W prime of T. Okay, that's the derivative of this thing. Well, the derivative of this function, if I take the derivative of, first of all, 15, that's just going to go away. If I do the derivative of this integral, remember all that's going to turn back into is my f of x function, or my f of t from up above. So this is going to be f of x, or f of t, it doesn't really matter. And then minus my derivative here is r of x, or again, r of t. Okay? I guess we should probably put these in terms of t's. And yes, we used x's up here to represent that top endpoint, but I just want these to match. So f of t, r of t. But this should make sense to you, because what this w prime of t is telling me is how fast is the water changing. Okay, what is the rate of change of the overall amount? And to figure that out, I'm going to figure out how fast is it entering, and I'm going to subtract how fast is it leaving. Okay, so this equation is all about rates. And if I want a critical point, I want to know, when does this thing equal 0? Well, the easiest way to find when this thing is going to equal 0 is to solve this equation, and I think I'm going to add the r of t to the other side. So I'm going to say, when does f of t equal r of t? Those are my critical points. Okay. For this, I am going to use the calculator, and so I am going to graph these. Let's see, and did it give me a specific, I guess it didn't really give me a particular interval, but I think we're going to be able to figure it out. So I've got these things in my graph. Let me just hit graph. I don't know what my window's looking like right now. I know for sure I don't want negative time, but so that's the first function. Here's the second function. Okay, so what I'm looking for is, when are these things equal, right? That's what I'm trying to find, is when are these equal. So based on my window, oh yeah, I have to make this a lot bigger. So my x can start at 0 because that's time, right? I don't know how far out to make my time go. I'm just going to go 10 seconds. I think my y's looked pretty good. Yeah, this looks pretty good. So this is my first function. That's f of t. Okay. Okay, so I need those intersection points, right? So I'm going to calc and intersect. First curve, second curve, guess. I should be able to just hit enter, enter, enter. And one of those times is at 5.051. Let's go find the other intersection point. I'm going to move my cursor to the left so that it's closer to that intersection. So you'll see my dot kind of moving to the left there. I just want to get closer to that intersection. And then I should be able to hit enter, enter, enter. So first curve, second curve, guess. And my other place is at t equals 2.267. Okay, let's think about what we do once we have a critical point. And I should have laid this out better so I have a little more space to work with, but that's all right, we'll make it work. What I'm going to do now to figure out where my maximum must be is I'm going to lay out a number line. Now my number line can start at 0 because I don't need negative time, but these are my numbers: 2.267, 5.051, and then I'm going to evaluate my function at some values in between here. Okay, and the function that I'm talking about, by the way, is this one, the w prime. I want to know, when is my derivative positive, when is my derivative negative, that kind of thing. Okay, so I'm going to pick a number like in between here. I'm going to pick a 1. And what I'm evaluating is f of 1 minus r of 1. There's actually a way I can do that on my calculator too. I'm going to go down here to y3, and I'm going to use my variables trick. So under y3, I'm going to hit variables, y variables, function. That's where I got to that list. And I'm going to say I want to do y1 minus, let's go back to variables, function, and I'm going to choose y2. So now I'll have a third function on there that is w of t, or w prime of t. It's this function minus this function. And that's where I want to evaluate this thing. So I think what I would like to do, actually I could probably just do this from my table. Let's do that. Okay, so at x equals 1, that's what this is. I want to look at the third function. So not this one, but my y3. And I'm seeing this is my value when x equals 1. But all I really care about is the fact that that's positive. Now let me pick something that's between these two numbers. So I don't know, maybe a 3. So let's go down to, whoops, didn't mean to go that way. Let's go down to when x is equal to 3 right here. And remember, my y3 function is that subtraction function, and this one comes out negative. And then let's just double check it with something less or something greater than the 5.051, so maybe a 6. I have to go back to my x's to be able to scroll down, which is a little bit annoying. But my y3 function here is also positive. Okay, so I've got my number line. The question is, where do I have a maximum? Well, this is my derivative, right, that we're talking about. My derivative is positive, so my function would be increasing. Here my derivative is negative, so my function would be decreasing. So I would say this value right here is my maximum, relative maximum. Okay, so you've done this a bunch of times, right? We did have to use our calculator to help us with like finding those intersection points and things like that. So if you do need to rewind that and watch that part again, that might be helpful to you. But this is the idea, is that if you're looking for a relative maximum, we know that we need to find a critical point. Critical point is when this thing is equal to 0. And then to find when it's equal to 0, I'm going to solve my two functions equal to each other and make my number line look for my maximum. Okay, that actually makes this next question way easier. Is the amount of water in the tank increasing or decreasing? Okay, do we remember this question? The amount of water in the tank, that's my W function, right? That's this W of t. That's talking about the amount of water in the tank. But if I want to know if it's increasing or decreasing, I want to know, is W prime positive or negative? Well, this W prime, and I should have labeled this here, that's what I just typed into my Y3 line. So I'm going to kind of do the same thing I just did. I want to look at 5 hours, right? So let's look in my table at 5 hours, and I want to make sure I'm looking at Y3, and I'm seeing a negative derivative here, okay? Because that's what Y3 is. My Y3 is W prime, okay? I'm seeing a negative derivative, and so that would tell me that I'm decreasing. So W prime, I'm just writing this so that you have it for reference, is equal to, according to my calculator, negative 0.2215, which is negative. It's less than 0, which means I am decreasing. The amount of water in the tank is decreasing at that time. Okay, and one more thing. What is the absolute minimum? Okay, so once again, we're kind of throwing back to stuff that we've already done. I want the absolute minimum volume of water, otherwise known as amount of water, on the interval from 0 to 8. Remember, this is talking about the W of t function that we created. And we're going to do a candidates test because it's absolute minimum. So I want to look at x, or I could say t. Sorry, I'm kind of changing my mind all over the place on t's and x's, but it honestly doesn't make a difference. So W of t is what I want to look at here. Okay. Now notice this is W of t, not W prime. So I'm not looking at this function. I'm looking at this function up here, W of t. And I want to look at this at the endpoints of my interval at 0 and at 8, and then also at my critical points. My critical points I already found, right? So my critical points are at 2.267 and 5.051. And don't forget that the reason those are critical points is that's when this function, the amount of water, is changing direction somehow. Okay? Okay. So I want to do the W of t function. That's this guy. And I can include, I'm going to include the 15 because that's technically part of the W of t function. I'm going to include it in all of them, so it's not going to change whether something is a maximum or a min, but I'm going to start by saying I'm doing 15 plus. First, I'm going to integrate from 0 to 0. Okay, so that should actually make life a little easier, right? That if I want the value at 0, when I integrate from 0 to 0, this is just going to be a big fat 0. And here, if I integrate from 0 to 0, that's a big fat 0. And so it should make sense to you that at time 0, all I have in there is the 15, because that's what it told us at the beginning, that 15 was our initial value. Okay, now let's actually use our calculator to do the calculation at 2.267. Sorry, I didn't think ahead on that one. Math number 9. I'm going from 0 to 2.267, and I am doing the, let's see, sorry, lost my train of thought there. I'm doing the y function, y1 dx, and then I'm subtracting the integral from 0 to 2.267 of the y2 function. What did I screw up? Oh, I forgot my dx again. I always miss that dx when it's off the screen. Okay, so at this time, at 2.267 hours, I have 21.023 gallons. These are all gallons. Okay, that should make sense to us because a minute ago we said that 2.267 is a relative maximum. So we actually could have gotten away without checking that one because what we're looking for is a minimum, but we would have had to say that this was a maximum. Now, if you had already solved for it up here and said that it was a maximum, you can just state that. You can say, we already know this is a maximum. But if you're going to use that kind of reasoning here and you didn't have this question up above, you would have to do all of this justifying for like, how do you know it's a maximum? And sometimes it's easier just to go ahead and evaluate it rather than doing all that explanation. Okay, I want to show you one more thing. And this is where I kind of trailed off a second ago because I was trying to decide if I wanted to show you at the same time. I have this w of t function up above that's 15 plus, and then it's this integral minus this integral. I can actually smash all of that together under one integral because my endpoints are the same. So I can say, really, I'm just going to do an integral from 0 to x of f of t minus r of t. Like I can smash that all together in one integral. That's just less typing in my calculator. Okay? So let's do that with the 5.051. So I'm going to say 15 plus math number 9, integral from 0, this time I'm going to 5.051. And I'm going to say y1 minus y2. Okay, all in one integral like that. I forgot the x, didn't I? I sure did. There's my x. Okay, and so at this time I have 16.058 gallons. Which again made sense because up here we said that from this 2 time to this 5 time, my derivative was negative, so I'm decreasing, and that's what I'm seeing happening here. Okay, let's check the same thing at 8. So I'm just going to do second enter and go back up here to this 5.051 and just change it over to an 8. Let's try it again. And look at that, that's a huge jump. I suddenly jumped to 54.195 gallons. Okay, so the question wants to know what is the absolute minimum. Well, the smallest amount of water I have is right here at the beginning. Okay, but I couldn't declare that for sure unless I checked these other points. I did have to verify that none of these others dipped lower than that 15 gallons I started with. Okay, so I would say the absolute minimum is 15 gallons, and that occurs at t equals 0. So the biggest thing with these questions is just understanding that you're going to set up an equation that tells you the total amount at any time. You're going to use those rate equations. You're going to build this equation that's based on integrals. I would name that equation something, and if you want to even make a note to yourself, like this is the total amount of water, okay? Then you can use that later on. And for all of these questions, these are all things that we've done a ton of times. How do you find a relative maximum? How do you find if you're increasing or decreasing? How do you find an absolute minimum? Okay? You just have to get used to doing that with functions that are defined up above. Okay? So you're going to try some of those tonight. We will definitely be practicing more of these problems as we go. Like I said, if you need to view any part of those calculator steps again, feel free to back it up and try it again. But we will take some time to go over the problem that you have in your homework packet tomorrow when I see you.